Boom Learning's card set together in case you're not able to make the call today. So this first question is saying, which of the following laws states that matter cannot be created or destroyed? And it gives us a nice handy hint here with 60 grams minus 40 grams equals 100 grams. And those grams can help you remember that we're talking about conservation of mass. Those are our units of mass that we use. All right, for this one, it wants to know what is the name given to the elements or compounds on the left side of the equation. On the left side of the equation, although we sometimes call them ingredients, the real name for those are the reactants. On the right side, we will have the products. So here it's asking us, what do we call these things on the right side? And those are our products. So if you start with 5 grams of carbon on the reactant side, how many grams of carbon should you end up with? And this takes us back to our law of conservation of mass. If we start out with 5 grams of carbon on one side, we have to have exactly 5 grams of carbon on the other side as well. Here it wants to know how many atoms of hydrogen are found on the reactant side. So our reactant side is right here on the left-hand side. And if we're looking at our hydrogen, we have a subscript of 2 with no coefficient here. So that tells us that we have 2 hydrogen atoms. For this one, how many atoms of carbon are found on the product side? So products is over here on the right. And we're looking at carbon, which is right here. We have no subscripts and no coefficients. So that means we have just 1 carbon atom. Identify the elements that make up the reactants in this equation below. So our reactants are over here on the left-hand side. So Hg, remember that we're looking at each capital letter on its own. So that H and G go together here. Hg stands for mercury. And then O stands for oxygen. And let's check that. This one's asking us to identify all the elements that make up the products side. So on our products, we have H, which is hydrogen, O, which is oxygen, Na, which is sodium, and Cl, which is chlorine. Identify the reactants in the equation below. So our reactants, again, are on the left-hand side. So our reactants, we're going to have 6 CO2, and we also have 6 H2O. Identify the products. Products are on our right-hand side. So we have Ag2S, and we have 2 NaI. Identify the elements that are found in this chemical equation. Now, the nice thing about the law of conservation of mass and the fact that nothing can be created or destroyed is we don't have to necessarily look at both sides of this equation to identify the elements. We can just pick one. So I'm just going to pick my reactant side over here on the left, just because that's where my brain normally wants to start out with. So I have Ba, which I believe is barium. N is nitrogen. H is hydrogen, and O is oxygen. Let's just make sure I have those ones correct. Phew! Here, same thing. We're going to identify the elements that are found in the chemical equation. We only need to look at one side. So I have Sn, which I'm not going to lie. I'm not quite sure I remember what that one is. So let's look up. Sn is the element symbol. Oops. Stannum. Stannum is the Latin name and it's tin. Okay, that sounds a little bit more, something a little bit more recognizable. I didn't recognize stannum there. All right, so Sn is tin. O is oxygen. And H is hydrogen. So this one wants to know how many total atoms are found in the reactant side of the equation below. So reactants are on the left. So we have 1 hydrogen, we have 1 chlorine, we have 1 sodium, 1 oxygen, and another hydrogen. So I count 5. How many total atoms are found on the reactant side of this one? Again, reactants is the left-hand side. So I have A, G, and I. So there's one of each of those, but that's going to be times 2. So here I have 2 atoms. I have Na2, which is another 2, plus S, which is 1. So I have 2 plus 2 is 4, plus 1 is 5.
Oops.
Oh. Let's see. What did we do wrong there? Oh, I see my mistake. Silly Miss Simon. I was looking at this and saying that I have AGI times 2, but really that's 2 times 2. So that's 4 plus 2 plus 1 is 7. How many total atoms are found on the product side? Our product is over here. Ooh, this one's got some extra steps in it. You know how much I like these ones. So I have 3 times Ba, and then in parentheses OH2. So I have O and H. Neither one of those has their own subscript, but they have a 2 outside of the parentheses. So that's 1, 2 times 2. So that's going to give me 4 there, plus another 1 here. So that's 5 times 3. So I have 15 here. Over here I have NH3. So that's 3 hydrogens plus 1 nitrogen is 4 times 2 is going to give me 8 here. So I have 15 plus 8, and if I do that right in my head, I get 23. How many total atoms are found in the product side here? So my product side, I have SN1 tin. And then I have H2O, which is 3 times 2 is 6. So that's going to give me 7 altogether. So then here is the chemical equation below an example of a balanced or an unbalanced equation. So we haven't learned how to fix unbalanced equations yet, but we have talked about how if it's a balanced equation, that means that you have the same number on both sides. Unbalanced means you have different numbers. So that means that we're going to have to just do some counting on each side of this equation to see if we're right, okay? So over here I have hydrogens and I have oxygens. I have 2 hydrogens in my subscript times 2 in my coefficient. So I have 4 hydrogens altogether and I have 2 oxygens. Over here on the product side, I have a 2 subscript for my hydrogens times a 2 coefficient, so I have 4 hydrogens, and I have no subscript here, so I have 1 oxygen times a 2 coefficient, and that gives me 2 oxygens. Since I have the same number of hydrogens on each side and the same number of oxygens on each side, that is balanced. Is the chemical equation below an example of balanced or unbalanced? So let's do this one again. Hg is mercury and O is oxygen. So here I have no Hg subscript times the 2. That's going to give me 2 hydrogens, and the same with my oxygen, no subscript times the 2 coefficient gives me 2. Over here, Hg, I have just a coefficient of 2, so I have 2 Hg, and then over here with my oxygen, I have a subscript, so that tells me that oxygen has 2. Again, since my numbers line up and are equal, that is balanced. Is the chemical equation below an example of balanced or unbalanced? I have Mg, H, and Cl. So I have 1 Mg, I have 1 H, and I have 1 Cl. I don't have any subscripts or coefficients on my my reactant side. On my product side, though, I can already see that I'm going to have a little bit of a problem. Let's see, Mg, I have no subscript, so that's just going to say 1. Hydrogen, though, I have a subscript of 2. That means I have 2 hydrogen atoms. And chlorine, I also have a subscript of 2. So if I look at this, my hydrogen and my chlorine numbers are not the same on both sides. So that means that this equation is unbalanced. And next week, we'll learn how you would fix that. Is this one balanced or unbalanced? We'll do the same thing again. So I have carbon, iron, and oxygen. Carbon over here, I have 3. Oxygen, I have 2 times a coefficient of 2, so I have 4. Sorry, that was iron. And oxygen, I have 3 times a coefficient of 2, and that gives me 6. On my product side, I have C, F, E, and O. And we'll talk about this more next week, but I write them in the same order, so it's easier for me to compare them. Carbon, I have 3 here. Iron, I have 4. And oxygen, I have 2 times 3, which gives me 6. And if I look at it, it looks like all my numbers line up on either side, and that one is balanced, unlike that smiley face I just attempted to draw. All right, on your deck, you're not going to see this one. They had quite a few questions where it was asking for balanced or unbalanced, and I didn't think that we needed to do quite as many of those. So then this one should show up on your deck. According to the law of conservation of mass, how many grams of hydrogen are needed in the equations below? This is easy. This is just like the math that Tommy's been doing, only with some bigger numbers, where they ask him a number plus 15 equals 40. And you learned a long time ago that when you are undoing addition, that you can do subtraction. So you can think of this as 40 minus 15. And you do not have to do this math in your head. I'm totally okay with you using a calculator. And if you do, you will get that your answer is 25. Same thing again here. 75 plus something gives us 250. So do 250 minus 75. And you get 175 for your answer. This one, 65 plus 35 equals what? And 65 plus 35 is going to give us 100. Here I have something plus 175 give us 500. So I'm going to do 500 minus 175. And 500 on my calculator minus 175 equals 325 grams. So then here I have, there we go. This methane model shown below contains which of the following? This one's a little bit tricky, but I thought I'd leave it in anyways. So it's showing me, just if you remember back to when we counted atoms, I have 1 here in the middle, plus 2, 3, 4, 5 atoms. I don't see that as a choice. I can also think of this as 1 molecule or compound because they're all stuck together. That's not a choice. And I can also think of it as I have a blue circle, that's 1, and I have white circles, that's 2, and so I have 2 elements present. And that one I see as a choice. Don't worry if that one was a little bit hard. That was just in there just for fun. Okay, so now this one with the law of conservation of mass is going to make us do a little bit more work. Okay, so I'm going to do 57 plus something equals what all of this over here is. So the first thing I want to do, because I am lazy, and I also want to make sure that I am not making any silly mistakes on my science with my math calculations, I'm going to do 34 plus 10 plus 26 on my calculator. And that tells me that that equals 70 grams. So now that I have a total for my product side, I can subtract the one reactant that I know. So 70 grams minus 57 equals 13 grams is what's going to go in that space with my red G. And I think that that might be all that you're going to see on your deck, because I think that I took some pity. I didn't want you spending all day on this, so I hid the rest of these cards, I think. Let's just double check. I think that might be it. Yep. So there you have it. In case you missed our call, there is an explanation for all of those problems that you're going to be asked to do for your homework today. I'll see you guys soon. Bye.